All right, hello everyone and welcome back to C Puzzles. We are going to continue and do the last puzzle in the Operators 3 Logic and Increment Operators section from the C Puzzle Book. For those of you that are following along, we are doing puzzles out of the C Puzzle Book by Alan R. Feuer. Feel free to pause the video and go ahead and try to solve Operators 3.5 before we jump back in to view the explanation. All right, here we go. Operators 3.5. Once again, we have our main snippet of code. We have our main function, and the statement we are trying to evaluate is the one here in teal/turquoise. We got the expression z is equal to x divided by plus x, followed by a call to the print macro with z being passed in as the identifier. In the top right corner, we have the variables and their values. Prior to entering the statement, we have x being the value of 3, y holding the value of 2, and z holding the value of 0. So in the line of code that we're trying to evaluate, we got z is equal to x divided by plus x. We have three operators in the statement. We have the assignment operator, which we've seen a plethora amount of times in our previous videos. We have the division sign or operator. And last but not least, we have the prefix increment, which we touched a little bit about in the previous video. So once again, which operator/operands do we evaluate first? The one with the highest precedence. In this case, it would be the prefix increment. We go back to our table of operator precedence and associativity. We can see in the second row, we have the prefix increment with its associativity being from right to left, respectively. In the following row, we have the division, which will have the second level of precedence with its associativity being from left to right. Going back to our statement here, we see that we got both. We got division, we got the prefix increment. Prefix takes the highest precedence, and we're going to be evaluating this from right to left. So starting from the semicolon and going from right to left, we see a white space after the x. We'll go ahead and munch that white space, and then we'll see that we can bind the plus to the value of x. And lastly, we can see that the next operator is the division. So ultimately, we have x divided by plus x as the expression, and then that value will be assigned to the value of z. However, this division x divided by plus x will give us undefined behavior. And you may ask yourself, well, why is that? Well, if we were to continue on and trying to assess this statement following the same rules that we have been applying in terms of associativity/precedence, we can see that, well, we would first have to go ahead and increment x first, right? Because we're following the prefix increment. So we'll go ahead and increase x being from 3. We're going to increment by 1 to be 4. And then here we can see that we have, two pathways to go about. We can say that, well, since we incremented x first, the value that x holds in the numerator should also increment. Therefore, we have 4 divided by 4. Or you can think of it as saying like, well, does the x value actually increment in the numerator or stay the previous value, which is 3? And then we have the division 3 divided by 4. Well, according to the C standard, this is not specified, and it could be any of these two depending on how the compiler decides to go ahead and treat this prefix increment operator. And you can see shortly here in the code what the compiler I'm using shows when I actually execute this code here. Here we have the snippet of code in VS Code here, and I have uncommented the last line 16 here, where we have the operators 3.5 here. Z is equal to x divided by plus x. Once again, call to the print macro here. Let's go ahead and try to compile this code right here. So compile this code here as we've done before. We get the warning for the return type of main, which is fine. And actually calling the executable here. We can see the result. The last value that's printed is value of 1, which is what the value of z holds. So we can see here that the compiler actually tried to go ahead and use the value of x as being 4 in both the numerator and denominator, and went ahead and divided 4, which gives us 1, and went ahead and printed 1 out into the terminal. Now, one thing we'll do here is when we compile this code, we compile the code without enabling any warnings, but I'll go ahead and here pass in a compiler flag -w all, which will go ahead and enable all compiler warnings that the compiler can give us when trying to compile the code. Now here we can see a whole list of compiler warnings. We're going to go ahead and ignore the first few, but let's focus on the very last one here. This one right here. We have the warning here. We have the quote saying operation on X may be undefined, and here in bracket it gives us the actual warning flag that is specified in the standard as -w sequence point here. Now let's go ahead and get a little bit more detail what this -w sequence point is and how this affects and how it actually applies to our actual compilation and this snippet of code. Have the definition of what is the -w sequence point compile flag warning from the GCC online documentation. Here is the URL that I retrieved this from. If you want to go ahead and peruse this for yourselves, feel free to do so. The sequence point statement says here, quote, "It is not specified when between sequence points modifications to the values of objects take effect. Programs whose behavior depends on this have undefined behavior. The C and C++ standards specify that, quote, between the previous and next sequence point, an object shall have its stored value modified at most once by the evaluation of an expression. Furthermore, the prior value shall be read only to determine the value to be stored. If a program breaks these rules, the results on any particular implementation are entirely unpredictable," end quote. So how does this apply to operators 3.5? Well, again, here we have the expression that we are trying to evaluate. We have what would be two sequence points. We have sequence point number 1 and sequence point number 2. Now, these two sequence points are my interpretation of how the compiler will go ahead and do the ordering of these sequences. According to the standard, there is not a specified way of determining what the sequence point would be. But in this case here, we can see that between these two sequence points, one where we're going to head and increment the value of x, and the other is going to use that value of x for the division, we can see here that it is unclear whether or not the value of x would be incremented, and then that incremented value would be used as the numerator or not. And once again, quoting from the online documentation, quote, "It is not specified when between a sequence point modifications to the values of objects take effect. Programs whose behavior depends on this have undefined behavior," end quote. So once again, the compiler can choose to have the old value of 3 as the numerator or the new value of 4 as the numerator in this division operation. But it'll be up to the compiler to decide and so forth. We saw after executing our code that the compiler that I'm using goes ahead and decides to use the value of 4 for the value of x for the numerator in the division operation. And then once again, 4 divided by 4 is the next operator that takes precedence, and then we have 1 as the result. And last but not least, we go ahead and assign the value of 1 to z, followed by a print macro invocation, which will just print the value of 1 to the terminal, which we just saw shortly a little bit a while ago. Now, before I wrap up this video, I'd like to go ahead and take a look under the hood and see exactly how the compiler is compiling this line of code by looking at the assembly code that gets generated from the compilation. So stay tuned for the follow-on video.